So this is the question we are doing down here. I'm speaking as if you guys aren't here, so uh, this is how we're going to start the question. So our first problem is to find the number of links, elements, joints, and degrees of freedom. So how we start is, maybe move on down. So how we start for this question is we are going to look at the number of shapes that we have, or surfaces that we have. And so for this question, they have them numbered, but like I said, in the future they will not. So 1 is the ground. You only count the ground one time for the number of links. 2 is this block here. Once again, another shape. 3 is this pinned, revoluted, slider. I don't know what you call it, bar. 3 there. And then 4 is also right there. So we have 4 links. Most people that sent me things got this one. So 4 is the answer there. And then we have to work on the number of elements. So this is the tougher one, I guess. So number of elements. So once again, how I would count them is, so number of elements is the number of modifications that had to be made to the links, or like points of contact. I think that's like a new thing I'm going to add to it. So points of contact. So for example, this right here is a point of contact, right, between 2 links. And so if there's a point of contact between 2 links, that is, and those are elements, right? So right here at between 1 and 2, there is 2 elements, because this one is coming into contact with 1, the ground is contacting 2. So this right here, that is 1 and 2, the first and second element. And then right here on this part, a hole had to be made inside of 2 here for this to be pinned. Likewise, a hole had to be made in 3 so that it could be pinned all together. So that is element 3 and 4. And then we move here. So similarly as over here, this slot had to be cut out, right? Because it didn't just, the material didn't manifest with that already in it. So that right here is 1 element as well. And the ground is contacting it here on this slider. And like I said, the ground is here, it is here, and it is here. So therefore, we have another 2 elements here, which would be 5 and 6, right? And then over here, we have 1 element. So element 3 here, or link 3, had to have a hole put into it, right? You would say right here for it to be pinned. And also link 4 had to have a hole put into it for this to slide all the way through. So that means this would be 7 and 8. Remember, any modification or contact with another link is what you count as an element. And then over here, similar to this one right here, we have 9 and 10. So the answer for elements is 10 elements if you add all those together. Alright. And now the next part is the number of joints. So the number of joints is basically all those like points of contact, right? What type of joints they are. So for example, right here where we counted the element earlier, this is called a prismatic or sliding joint. So I'm just going to put sliding. So that is 1 joint, and it is a J1 type. And then here, this right here is a revolute joint, so I'm going to denote as rev. Because a revolute joint means that all it does is it can rotate with respect to the other thing it's attached to. So revolute, and this one is also a J1 type. And then right here is, I think, our first real encounter with a J2. Maybe I'm mistaken, but this right here is a J2 because it is a roll slip. So basically what a roll slip means is that this thing can slide this direction and this direction, right? But if you turned this upward, like if you took that and raised it with your hand, it could also roll along that pin as well. So that is a roll slip, which means that this is a, let me do roll slip, and that is a J2 type. And then right here, another revolute joint, right? So this is rev J1. And then over here, same as the other one, we have a roll slip again. Another J2. So if you take all those and add them together, you should get 5 total joints. 3 J1 and 2 J2s. All right. And then the next part, which is the degrees of freedom. So degrees of freedom, essentially, as I said in lectures past, is that it is the amount of motion that this mechanism is allowed, right, to move. And so as you add links, using joints, it reduces the degrees of freedom that you can possibly have, right? You can't be free to move in all directions if things are attached to each other that limit that movement. And so this is a mechanism, and so because a mechanism is defined that it is grounded at some point, so essentially it's a chain, it's links that are grounded at one point or another. So, and the equation for degrees of freedom at a grounded point, or for a mechanism, is 3 times n minus 1 minus 2 times the number of J1s we have minus 1 times the number of J2s. And that is because when you do J1s, which are revolutes, slidings, and rollers, they reduce the amount of degrees of freedom by 2. And J2s reduce the amount of degrees of freedom by 1. And if you do that calculation by inserting the links here and the number of J1s and J2s into this spot, you will get the degrees of freedom to be 1 at the end. So it would be 3 times 4 minus 1, which is 9, minus 2 times 3, which is 6, right? And then minus 1 times 2, which is 2. So you get a total of 9 minus 8, gets you 1. And then we have the last part, which is the binary and ternary links. So this number should always match how many link binary and ternary you have together. So if you have 4 links, this better be 3 and 1, 4 and 0, 2 and 2. It has to add up, or else you didn't count right. So the number of binary links. So let's start out with link 1. So link 1 is the ground, right? It is here, it is here, and it is here. So link 1. How many elements does link 1 have? And remember, so what it means is that an element is a contact point or some sort of modification had to be made. So if you count this, we have one slider here, which is one element. We have it pinned right here, and it's sliding in between here, so that is another element. And then we also have one up here, same as that one, which is 3. So that would mean that this is a ternary link. The ground is a ternary link because it has 3 points of contact / 3 modifications had to be made for it to be in contact with another link. So I will put 1 there, or that's one ternary link. I'll just go ahead and put a T on it. So 1 equals turn. Now 2, get rid of this. So link 2 is this block. So link 2 is this block. For however many elements, it had to have 1 rolling contact here. And if you take away this pin, so like let's say we just removed it, you would see that 1 hole had to be added to, which means that this is a binary link because it only had 1 modification and 1 point of contact. So that means 2 is a binary Link 3 has one hole made here, one hole made here, and this sliding pin thing was added, which means that 3 is a ternary link because it once again had 3 points of contact slash modifications had to be made. And then this one was modifications, right? They're not point of contact really, it's modifications. So you had one hole here, and then this big hole in the middle. And then 4, if you removed this right here, like if you took away link 3, you would see something like this. And you would see that one hole was added right here, or else these two aren't pinned together. So one hole added right here. And then another hole had to be added in the middle for this slider to work. And the reason, so this one is basically the exact same as 3, only there is nothing connecting at the top, which means that we lose one element. Therefore, this is a binary link. So, binary link. So that means there are 2 binary and 2 ternary for this question. And I think that solves the whole question. Let me make sure I didn't miss anything at the top. Binary, links, elements, joints, degrees, freedom. Yep, so this is it, except for the skeleton drawing, but I didn't require you to do the skeleton drawing. So this is how the question was done. If you guys didn't get that and you don't know why, go ahead and ask. But if what I just did explained it fairly well, we can move on to the next question. I will give 15 seconds before we move on. Any questions? And Junlin, at the end of the class, I will talk about your specific question in a second, or at the end, once we've done it all. All right, so I'm moving on. So I'm going to get rid of this, and we're going to move on to the next part. And so the next part is going to be, I really want to do this one, but I don't think that's a good one. Let me go ahead and pull up another question. All right, I promised you guys yesterday that we would do this one. Where is it? I want you guys to do this one right here. So we are doing that question. And I want the exact same thing. I want the links, joints, elements, degrees of freedom. You guys know the drill by now, hopefully. And so this is the one I want you to do. And once again, so what you should do is, this is how I do it, is that I would, so this one, by the way, is not numbered, and this is how your exams will look. They will not be numbered, so you will not really know how many links there are off the start. So you have to count your own shapes. So I would just go through and do, you know, your 1, 2, 3, etc., right? And count the number of links. And you are good to go now. I'll go ahead and write what we're expecting over here. So links. And once you have the answer, you can just send it to me in a message. Alright, and that should be it. Now, I'm going to give probably another, because this one I don't think is really that bad. So I'm going to give probably 10 minutes. So at 50 after, I'll explain how to do it, and then we'll be done. So all right. And then DOF. Oop, got an answer. Who is this? Hector, you are correct. If that's what your name, I know your Discord name is different, so it's hard to tell. But I think that is you. And if you do not need it explained as to how you got the answer, once you've turned it in, you can leave. So if you need to go, Hector, you can go since you got it right. But if you want to hear that other question explained at the end, the one that we did yesterday, you can stay. But and so tomorrow, what we will do is we'll very quickly review this. I'll probably just go through the things again, like what it is and how we do it, and then and then after that, I will start chapter 2, which is vector loops and acceleration and velocity analysis. That is probably the hardest chapter in the class. Sean, so you have the number of links correct. You have the number of J1s, J2s, and degrees of freedom correct, it appears. And but binary and ternary, uh, I would revisit that, and the number of elements. Got about 4 more minutes, and then I will go through it, and then we will be done for the day. Yes, you are correct, Sean. So what you've just sent me is right. Yeah, I figured you had it flipped because you had the opposites, but very good. So like I told Hector, if you don't need it explained, you may leave. But I'm going to finish the video with the explanation just in case someone needs to come back. All right, and Jackson. Jackson, you are also correct. So Jackson has just asked a good question. So he asked, why do the revolute joints not count as links, even though they are shapes? So you're saying, here, let me draw it for us really fast. So you're saying, well, I wish I, so this is why I should use Paint 3D, because Paint 3D you can actually make these shapes. So you're saying that, like, for example, link this one right here, right? You're saying, why don't these shapes, so like when you cut these holes out, these are shapes, right? And why don't they count as why don't they count as links? Is that sort of the question? Oh, okay. You're saying you're talking about the grounds, specifically the grounds. Okay, that makes a little more sense. So he's asking this right here. So if anybody played Pokemon, this is like a Diglett. So this thing right here, right? He's asking when it is connected to a shape, like why? So why don't we count this one, right? Why don't we count this one as a link, even though they are shapes? So the reason is because it's just this right here is an extension of the ground, right? So if you're grounding something in real life, you never just really attach it to the ground. Like if so here's an example. Have you ever seen like those big telephone towers that have like those long cables that go down to the ground? Those are attached to the ground, but they are attached not just they didn't just bury it in the ground, right? They like pinned it really hard to the ground using something. They shot it deep with like some huge like you know it's not a bolt, but it might be. But essentially they shot it really deep into the ground. This right here is essentially just it's a extension of the ground. We added a piece of hardware so that it could revolute around that point, but it's just attached to the ground. That is why. So we extend the ground out because this is just the ground, more or less. So basically, when you see something like this and it's grounded right here, this is where you should write 1. If you're counting link 1 as the ground, you should write it like that. And it's also link 1 up here as well. Yeah. But you're right, it is a shape, so no, that shape thing, like it was just whenever I did the class, I specifically remember me not knowing. This is gonna sound dumb, but now that I'm doing it, but I was struggling on this chapter because I had no idea how to count these things. Like I completely had no idea. And my friend, who is now works at a nuclear power plant, I still talk to like every day, but he was sitting next to me, and I told him, I said, I told him, can you put this in the dumbest terms possible for me? I told him to, because I said, I am dumb, put it in the in the easiest terms possible. And he literally wrote out what I wrote. He goes, links, shapes. And that is how he did it. He wrote links equal shapes, joints equal shapes attached, elements equal contacts and changes. Like, he literally wrote it out that way, and I ended up getting a better score on the first exam than he did. So it completely clicked once he wrote it like that. So that is the reason why I tried to do it. But I know for some people, most people don't think like me because I am probably insane. But it worked for me, and I was hoping it might work for you guys as well. Let me check these other ones right here. So, Ahmed, so you have J1s and J2s are correct. Degrees of freedom is correct. So your binary and ternary are not correct because that is incorrect number of links. You probably counted these as links, like we were just talking about. You're two off of the correct answer, and you also are missing an element. So go back in, revisit that, and then let's go look at Junlin. So, Junlin, you are correct. So, like I said, you may go. Well, we're already over the time anyway. Yeah, you guys got to keep me on point, or I'll keep talking forever. So, real quick, I'm going to do the question. So, but I'm going to do it very quickly to get everybody out of here. But if you want to leave, if you got it right and you want to leave, you can. So, real quick. So, the number of links, I'm going to count them out. So, links, once again, are shapes, but not counting the ground twice. And these are extensions of the ground. So, you would count this. I would mark this as 1, 2, 3, 4, and 5, because this would be the ground again, which is also just 1. So that is the first one. Let me get back to the page. So this is 5 links. Number of elements. So once again, this is the number of modifications or contact points between links. So if you took this piece away, this guitar pick right here, you would find that it has 3 holes, right? There's like, or this is a pin, this is a hole, and this is a hole. So therefore, we had to make 3 modifications. So that is 3 elements. So I'll make a tally over here. But this isn't generally how I would do it, but maybe this will help a little better. And then if we look at this link, number 2, this right here is 1 hole and 1 hole. Therefore, we had to add another 2. So that's 5. And then if we look at this big, slightly different guitar pick, this Dorito, there's 1 hole here, 1 hole down here, and we had to cut this hole out. So that is another 3. So 1, 2, 3. And oddly enough, these are also the binary and ternary links, but we'll get to that. And then if you take this right here, you had to cut a hole here and cut a hole here, so that means we added 2 more. So that is 10. And I did not count the ground yet. The ground, there is 1 pin / hole here, and 1 up here as well. So that counts as 2 more. So there should have been 12 elements for this one. And then joints, we have 1 revolute here, 1 revolute here, 1 revolute here, 1 slider here. So this is 1, 2, 3, 4, 5, 6 joints, if I got that right. Yep, 6 joints. But there are 5 J1s and 1 J2, because this right here, J1, 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 J2, because this is a roll slip. So I'm going to put 6 here, but there are, so it's 5 and 1, essentially. 5 J1s, 1 J2. And then degrees of freedom. This one, once again, if you do that equation, which is 3 times the number of links, which is 5 minus 1, minus 2, number of J1s, which I guess I should just put that in there instead of being lazy, minus 1 times 1. And if you do that equation out, you get 12 for this one, minus 10, minus 1, which gets you a DOF of 1. And then we have binary and ternary. So binary and ternary. So what you would do here is you go up to binary, which are the number of links that have 2 elements. So this right here, we'll start with the ground. The ground has 1 contact here and 1 contact up here, which means the ground is a binary link for this question. So 1 binary so far. Let's go to 2. So 2 is this guitar pick thing. So we have 1 hole here. You had to put 1 hole here, and there's 1 pin attached to it here. So that means that that is a ternary link because we had 3 different modifications that had to be made. And then if we go to link 3, we have 1 hole here and 1 hole here. That is another binary because there are 2 elements. Link 4, 1 hole up here because this had to be pinned through it, right? 1 hole down here, same as the other reason, and then 1 cutout had to be made for the slot, which is another ternary link. And then link 5, this is the same as link 3, just longer. 1 hole here, 1 hole here, therefore binary. So it is 3 versus 2 for binary and ternary links. So that is the answer to the question. If you have any questions, once again, if you did not get the right answer, you can stick around, but I'm going to explain another question to Junlin really quickly, but I'm going to stop the video here. So let me do that.